Okay, here it is, the final page and our final theorem, for this lesson at least. It's called the angle bisector theorem. It says, if a ray bisects an angle of a triangle, it divides the opposite side into segments that are proportional to the adjacent sides. Okay, so in this, we are given a triangle, and it's hard to see here, but this is vertex A right here, A, B, and C. And we are told that segment AD, or ray AD, bisects angle BAC. So you can see it's marked with congruence marks here. Okay? And what we're trying to prove is we're going to try to prove that BD, this segment, over DC is equal to AB over AC. Okay, so my given is stated. And step number 2, we can tell since these two angles are marked congruent that we need to put it into our proof. So we're going to say that angle 1 is congruent to angle 2, and that is by the definition of an angle bisector. Okay. Now you can see that there are some dashed lines here. So what we're going to do in step 3 is we're going to say draw through, I'm going to use an abbreviation for this, through point B, the line that is parallel to segment AD. Okay? So here's segment AD, and we're going to draw a line through point B that's parallel to it. So I'm going to mark these with parallel marks. Okay? And the reason for that is the parallel postulate. So through a point that's not on the line, we can draw one and only one line parallel to the given line. Okay, we haven't seen that one in a while. Here's number 4. We're going to extend side CA so that it is going to intersect with this new line that we drew, and it's going to intersect at point E. Okay, so I write extend line CA to intersect the parallel line at E, point E. Okay, and the reason we're going to give for this is that a line, because we know it goes on forever and ever in each direction, a line can be extended. Okay, let me move this up a bit. Okay, number 5. Okay, so now that we have this, we're going to focus on the big triangle here, which is triangle EBC. Okay, and I'm going to state that, BD over DC is equal to EA over AC. So let's see what that is. So BD over DC is equal to EA over AC. So we're using the fact that we have these two parallel lines, and they are going to split the sides proportionally. Or this one is going to, segment AD is going to split this side and this side proportionally. Okay, so that would be our side splitter theorem. All right, so number 6. If we focus on the fact that we have two parallel lines, and let's call this the transversal that we're going to focus on right now. Okay, so I have two parallel lines cut by a transversal, you should recognize that these two angles are congruent, and that is by alternate interior angles. So I'm going to write that angle 1 is congruent to angle 3, and that's because alternate interior angles are congruent. Okay. You might also notice that I have angle 2 and angle 4, and that these two angles would be congruent. I'm going to use the same mark because angle 2 is already marked for me. And you should notice that now I'm talking about this transversal CE, which isn't perfectly straight, but we're going to imagine that it is. Okay, and it's still cutting through these two parallel lines, and so now it creates these two corresponding angles. Okay, so I'm going to say that angle 2 is congruent to angle 4, and that's because corresponding angles are congruent. Okay, don't want to lose my picture here. I have to squeeze this in. Okay, so number 8, I'm actually going to state that angle 3 is congruent to angle 4. We can clearly see in the picture that angle 3 and angle 4 have the same mark, but the way we need to write it in our proof is we need to figure out how to use this information that comes before it to conclude that angle 3 is congruent to angle 4. So if you can go follow my reasoning here, if 3 is congruent to 1 and 1 is congruent to 2 and 2 is congruent to 4, then 3 has to be congruent to 4. So this is a transitive property reason. Okay, so number 9, hopefully you're thinking ahead. Now that I have these two angles that are congruent, and you can see that I've got a triangle here that looks like an isosceles triangle, we know that if two angles of a triangle are congruent, then the opposite sides have to be congruent. So I'm going to state that segment EA is congruent to segment AB, and that is by this reason. If two angles of a triangle are congruent, then the opposite sides are congruent. Okay, and I'm almost to the end here. I'm going to move this up a little bit. What we're trying to prove is that BD over DC, and we have that so far. We're trying to prove that it's equal to AB over AC. So we have to figure out a way to turn this into AB, which we now have in step number 9, because we now know that EA is congruent to AB. Oops, you can't see that there. Okay, so I'm just going to write number 10 right here so we can still sort of see the diagram. So number 10, I would just do my substitution and say that BD over DC is equal to, instead of EA, I'm going to write AB over AC. Okay, and step number 10 is just substitution. Substitution property. So if I want to be specific, I can say that I substituted what I knew from 9 into step 5. And I guess with our transitive property, we should talk about the fact that we use step number 2, which is right here, step number 6, and then step number 7, just to make it clear. Okay? All right, so we have an example problem. We are going to try to find the measurement of angle of side X. Okay, so now that we know our angle bisector theorem, we know that the sides are in proportion based on that angle bisector. So there's a couple different ways we can do this. Let me go up here for a second. What we proved up here is that this segment over this segment was equal to this segment over that segment. But we can actually set it up a little bit differently. We could say that AB, this one, over BD, this one, is equal to AC over DC, because we're still going to have the same relationships on the diagonals. So BD times AC is still right here, and then the other diagonal is AB and DC, which now we have there. So I like that setup a little bit better for this problem. Okay, so I'm going to say that, I'm going to actually show it to you before I put the numbers in. I'm going to say AB over AD, AB over AD is equal to BC over DC, okay? And I can use this because I know that BD is an angle bisector because these two angles are congruent, okay? So now I'm going to substitute the numbers in. So I say 6 over x is equal to 4 over 2. And that gives me 4x is equal to 12, so x is equal to 3. Okay, so I just wrote you a note to please take a look at problems 4 and 5 at the top of page 354 before beginning this assignment. There's some really good proofs. They're pretty simple. They're 5 steps a piece, I believe, but there's some good proof problems to just give you a little more practice with the proofs. And here are the problems that I'd like you to do. And enjoy! See you on Monday, hopefully. Bye.